All right, number 97 on page 907. I actually like the bouncing ball problem for test questions. As you work through the practice test, you'll probably see that it's a common question, so it's good that people asked. So using a certain ball rebounds to half its height from which it's dropped. Use an infinite geometric series to approximate the total distance. That's what makes this one a little tricky. The ball travels after being dropped from 1 meter above the ground and comes to rest. So we drop the ball from 1 meter, 1. Ball starts here, it drops to there. And then it rebounds to half the height, and then it drops back down. So it goes up, and then it comes down. And then half of the half. 1/2 squared. And on and on and on, forever and ever, theoretically. So I like to, there's more than one way to do this, but I like to create this as two geometric series. Or, no, I think I like to do it as one geometric series, and then you add 1 to the end. So here's how I'm going to do it. These are all doubled, the ups and the downs. This one is a solo by itself. So I'm going to say the total distance traveled is 1 plus 2 times these values all added together. That's a 1/2 plus a 1/4 plus a 1/8 plus a 1/16, on and on and on forever. Half of a half of a half. Now, you guys probably just know this sum because we've done it so many times in class now. But I'm going to pretend we don't know it. The first term is 1/2. The common multiplier is 1/2. Since this is between -1 and 1, it converges. So there is a sum. 1 plus 2 times. So I need to kind of put the formula for the infinite sum. A1 over 1 minus r. So it's your first term over 1 minus your multiplier. So that's 1 plus 2 times, this is 1/2 over 1/2, which of course is 1. 1 plus 2 is 3. So 3 meters. All that work for just 3 meters. It's because this all adds up to 1. So that all the downs add up to 1. All the ups are another 1, and the initial is another 1. So 3.